Hello, I have notes for page 631, 7 through 10. Okay, simplify the radical expression. If you look at example A here, we have 20x to the power 6 y cubed. Okay, 20, we're going to make a factor tree and find the factors of that. We have 5, 2, 5, and 2, so we're going to rewrite this as 2 times 5. Okay, and then x to the 6th is 6 x's, 1, 2, 3, 4, 5, 6, and then 3 y's, 1, 2, 3. Okay, and the pairs can come out as 1. We have one pair of 2's, we can pull out a 2. We have 1, 2, 3 pairs of x's, so I can write x cubed. I have, now, when you're going from an even exponent under the root to an odd exponent on the outside of the root, you have to put absolute value signs. Okay. Now y cubed, we have 1, 2, 3. We have one pair for y there. Left under the root, we have a 5 and a y. That's your final answer there. Okay, again, notice we don't have absolute value signs around the y because we're going from odd exponent to an odd exponent. It's only when you go from even under the root to odd outside of the root. All right, next one. We have 99. We're going to write the prime factorization of that. 99 factors to 9 times 11. 3 times 3 times 11 is 99. I'm going to write this as 3 times 3 times 11. M to the 5th, 5 m's. 1, 2, 3, 4, 5. We have 2 p's and then 4 r's. Okay. We can pull out a 3. One pair of 3's. Okay, the 11 has to stay in. It doesn't have a pair. We have 2 pairs of m's, so we can pull out a m squared. We have 1, 2, so the exponent's 2. 2 pairs. We have, notice it's going from underneath, it's odd. It's under the root and the exponent's odd. We don't have to worry about there being an absolute value sign. But for the p's, it's p squared. It's going from even to odd because we have one pair of p's. So we got to put absolute value signs around the p. And then we have 2 pairs of r's. So since we're going from an even to an even, we don't have to have absolute value signs. Okay, r squared there, because we have 2 pairs. Left under the root, we have an 11, and then 1m. And that's all that's left under the root. Okay, notice it's only when you're going from having an even exponent under the root to having an odd exponent outside of the root that you need the absolute value signs. 2 to 1, and up here it was from 6 to 3. Okay, let's see if it happens down here. Problem C again, prime factorization of 44. Got 4 times 11. And that's 2 times 2, so 2 times 2 times 11. Times A, we got 6 B's. 1, 2, 3, 4, 5, 6, and then 5 C's. 1, 2, 3, 4, 5. Okay, pair up what we can. We have 1 pair of 2's that's going to go out. We have, okay, the A will have to stay under. It doesn't have a pair. We have 1, 2, 3 pairs of b's, so that's going to be b cubed. Notice we're going from an even exponent under the root to an odd exponent outside of the root, so we're going to have to include those absolute value signs. We have 1, 2, 3, 4, 5 c's. We have 2 pairs under there. So that's c squared. And then left under the root, we have 11 times a times c. Last example here. We can rewrite 45 as 3 times 3, that's 9, times 5 is 45, all over 2 times 5. Okay, notice I rewrote 10 as 2 times 5, and I rewrote 45 as 3 times 3 times 5. Okay, 3 times 3 is 9, 9 times 5 is 45. Okay, now we can divide out the 5s. So this is equal to the square root of 3 times 3 over 2. Well, the square root of 3 times 3 is 3, so this is equal to 3 over the square root of 2. This very last step is new. It's called rationalizing the denominator. We're going to times the top and the bottom by the square root of 2. Okay, you get 3 root 2 in the numerator, and the denominator, the square root of 2 times the square root of 2 is 2. So the answer to that one is 3 root 2 over 2.